Now we're going to talk about how to name compounds with polyatomic ions. Remember, polyatomic ions are ions that have many atoms. You have a polyatomic ions reference sheet that you can use to look up any of the ions used here. Now, when you name polyatomic ions, again, the first thing you do is name the cation. And then the second thing is name the anion. Now keep in mind that in these, one or both of the cation or anion can be polyatomic. So it's just good to get familiar with the polyatomic ions so that you can identify them. Let's go ahead and look at an example. So let's say we have, I'm going to do this in different colors again. Okay, so let's say we have this compound. The first thing that you need to do is name the cation. Remember, the cation is always the one that's written first. So the cation here is magnesium. This is an element, it's an elemental ion. And so we don't have to worry about the polyatomic ions here. Now remember, in an ionic compound, there's only a cation and an anion. So now that we've named the cation, that tells me that the remainder of this compound must be the anion. Even though there's more than one element here, there's nitrogen and oxygen, I see that there's a group of elements right here that are not part of the cation, therefore they must be part of the anion. So the anion is NO3, and that, if you look at your polyatomic ion sheet, NO3 minus is the ion called nitrate. Okay, so this is nitrate. And so when we put it together, the name of MgNO32 is magnesium nitrate. Magnesium nitrate. Let's look at another example. Let's look at one that has a polyatomic ion first. Okay. So again, we need to name the cation. And in this case, we can kind of use these parentheses to let us know. Now, this is not always the case, okay? This subscript here tells me that there are two of these NH4 plus ions. But the parentheses are kind of a clue in this case that separate this group of elements from this element, okay? So, when we look at this chemical formula, the anion is NH4. And when we look that up on the polyatomic ion sheet, we see that ammonium, that's should be a U, is NH4 plus. So the cation is ammonium. And then the anion is oxygen, but oxygen is O2 minus, and the name of that ion is oxide. Okay, and so when we put it together as a whole name for the entire compound, we name it ammonium oxide. Okay. Now just a quick note, if we look at this, let's look at this example again, NH4, 2O. So what this is NH4 is ammonium, and that is NH4 plus, and oxygen is actually O2 minus. And so when we look at these charges, remember when we looked at the formation of ionic compounds, we have a 2 minus charge, meaning that this oxygen has gained 2 electrons, okay? But over here, this ammonium has a positive charge, and what that means is it's only lost 1 electron. And so if this guy over here, if oxygen has gained 2 electrons, then that means that it's had to gain them from 2 ammoniums. So it's gained its electrons from 2 NH4 pluses, since this is only donated 1 electron. And so when it forms a compound here, we represent that gaining of 2 electrons, or that 2 ammonium ions with this subscript of 2. And so I don't want to confuse you too much right now, but if you're wondering, that's where that 2 comes from, and it's because of this balancing of charges between the 2 ions.